How did this go?
Hello, my name is Davidlohr BUESO. I work on CXL at Samsung. This talk is mostly about bringing a way for users to communicate or send commands to the different types of, the different ways that CXL allows it within the direct attached domain. And it's really a unification or based off of what FM API tests paved the way for a way of communicating through standard commands with different components. And added to that, the kind of administrative wrappers or interfaces that libnvme provides. And if people are familiar with libnvme.mi, that's exactly what this is about. Yeah, and it's scoped by the manageability model of CXL devices as well as the CCI. And this library could also be called libcxlmi, really. So this is not intended to compete, replace, or do anything with libcxl. It's really mostly about not having the protections that the OS gives us for communicating with devices. So basically users have to know what they're doing, and if not, they get to keep the pieces. And it supports both out-of-band and in-band CCIs, but it's really mostly about out-of-band. And potential users are BMCs, fabric managers, firmware, whatever. And the reachability is what FM API tests kind of modeled with the Type 3 SLDs, MLDs, and CXL switch. Again, it does not support GFAM devices. And there's no concurrency. It tries to be indenness aware, at least for the non-vendor specific things. And the idea for this is to have a standard and open building block for building fabric managers and dealing with BMC. And right now, this is very obscure and fragmented, I think. There's no clear open source software there's very little information about what's going on. And this was previously discussed with the DCD kind of loop. So I'm not one to put code in slides, but I think instead of going through all the different library calls, it's better just to show by example. This is really just an MCTP component discovery using dbus. Here you basically discover all the components within the system. And there's really two library-specific components, which is the library context that keeps track of all the open endpoints, and the actual endpoint, which is whatever MCTP will discover or whatever Linux has for the SysFS devices and how you do the IOCTLs. So here you're basically discovering everything that there is to discover and iterating through each of the endpoints and basically showing some trivial information. That's really what this is about. And there are really three ways of discovering things or opening them. One is passing the tuple, the network ID, and the endpoint IDs for MCTP. Linux does the MCTP stack. It includes the network ID, sort of like an address space, work around to not be limited by, I think it's 255 devices, something like that, the maximum. So you can basically open everything. You can open one at a time, or you can just do the old-fashioned libcxl way with Linux. When probing or opening devices, I call them endpoint. Again, endpoints is a very generic term. The library can track different instances of the same underlying device, but it is limited by what the spec dictates, that there needs to be a one-to-one MCTP and mailbox. You can also do it for secondary mailboxes if like, I know Linux doesn't support secondary mailboxes, but in theory, there's nothing that would prevent having it. And the calls are really all about expressing what command to send to what endpoint and how. You can do it directly or the tunneled way, as we're going to see. So the functions themselves, they're called as best as possible the same as the payload data structures, keeping it simple. It can be like a mouthful to type and all, but it's really pretty intuitive. The 80 character width really is really hard to follow. So yeah, and it's really like, depending on the payload, you get the kind of function that you want to use. So commands that don't have any payloads, they'll just have the endpoint and the tunnel information. And the ones that have input payloads only will have its input parameter, output parameter, or if they have both, they'll have both. And the data structures themselves, the payloads, are basically exporting exactly what the spec says. So users are expected to know what they want to get from this. So normally for the tunneling information, if you just pass null, you're referring to the direct communication. But the more interesting use cases are obviously with the tunnels, and the spec has 3 that are not GFAM basically. So for to send, the first example is tunneling commands to an MLD through a CXL switch. The spec diagram is pretty straightforward. And basically all you have to do is arm the parameter with the level you're using. Normally it's 1, but you can also have two levels of tunneling. And if you're sending it to a switch, in this case, you give the port number. And that's pretty much it. Very similar when sending to an LD within an MLD. You specify the LD and you just pass it. So again, very straightforward. And the double tunneling is basically you set the level and you set both the information for the outer tunnel and the inner tunnel. And yeah, that's all that's required. The return values, usually -1 with error no set, or the respective CXL return code. And of course, like in this example, you can't always check for if error or if RC, whatever, because if it's a background command, you have to keep that into account. Silly things like that are necessary to give users the most flexibility as possible. And this is really what I wanted to open up the floor for. Is this sort of thing useful to the community? There's been no release. I know that some people are already using it successfully and are pretty happy with it, but things can change. A lot of testing is very hard for this sort of thing. QEMU has opened a lot of doors for this thing, and I think that the increasing interest in out-of-band use cases are making QEMU was always very tied to the kernel development side of things, and now it's really not necessarily only that. Now it's people are wanting to have the testability of QEMU for this sort of thing. So it really expands the necessity of the emulation. Yeah, the current state of the art uses the A-speed I2C. That's pretty much all we have for testing right now. But it has been successfully used with the SMB bus.
This looks great. I think we're happy to join forces with you. We have something very similar internally, but we haven't, we were planning to open source it at some point if no one else did. And, but we can, I'll talk to you after, see how we can work together.
Yeah.
Throw a trivial request on there, which is if anyone has an MCTP device that they can publish a spec for, that we have any realistic hope of integrating with upstream QEMU, it would be extremely helpful. The thing being used here is an appalling hack. I mean, it's bodged into x86 PC, as they all have A-speed I2C controllers on them. I mean, it works, but we also have to hack the kernel drivers to make it work.
Yeah.
So it's a bit ugly. So if anyone has any real hardware, it'd be very, very handy.
And if anybody is going to test this with real hardware, I'd really like to have input on it, because again, right now most if not all of the testing I've done has only been with QEMU. The one thing that's open is the tunneling through the for MHDs, and basically adding the rest of the commands. I haven't looked at the GFAM devices. But the idea ultimately, I got this question, is it not supported? Will it never be supported? Or is it just not supported now? I think that this library should have the same reachability as CCI in general. If you can send a command to a device defined by the spec, this library should be able to do it. But for now, the tunneling we have has proven useful for the use cases we know that have this.
Well, having done libraries like this in the past, I do kind of wonder about defining the header file with particular payload responses and how that will fit. I guess if everything's in a spec, it probably is pretty safe.
Yeah.
But then that led me to ask the question, why not Rust or a different language? Is there any thoughts on doing that?
I'm a C guy, but
I mean,
Rust wrappers, I totally see it. Unlike the kernel, I totally see Rust wrappers because fabric managers are planned on being written in Rust. At least I know a couple of cases. So
actually, that's right. I heard somebody.
Yeah.
Two things. The one is that, as you mentioned, libcxlmi. We found it quite helpful for just implementing all features and everything, just to have a test spec for the spec itself, just to see right where do we stand. That's one. So that's quite helpful. The other one is you maybe want to talk to Javier, because they have built a scraper for the spec file. So you can scrape the header files of the spec file, which turned out to be incredibly useful, because then you're reasonably sure you didn't make any typing mistakes when creating the header files. And you can even then validate whatever's in the spec, whether they didn't mess up and defined a bit twice or stuff like that, which never happens, obviously.
No, never.
So you said earlier in one of the slides, the intent is to, I guess, not compete, if you use that word, with libcxl or CXL CLI, or however you want to interact with it. In that sense, there is some level of duplication of functionality.
Yeah.
Is the intent, and I guess this might be more on your side, is the intent to keep libcxl more for the kernel-specific management, like the inbound side, and have this more focused out of bound? But obviously, you can do the inbound management via this as well?
That's exactly the approach I took. I did not want to contaminate the NDCTL library, just because the libcxl is so Linux defined.
And yeah, I want to keep that straight, because like my mental model right now is NDCTL being the parent package for it seems highly tied to the kernel version you're running on, and if you can decouple that from, I guess, the CXL
Yeah.
general CXL kernel stuff.
Yeah, and we also have this firmware control interface we're talking about. We're thinking about calling it auxiliary control, but that's about having a path to send like unfettered vendor-specific commands, but also we also need to support the libcxl interfaces. So I think we need to do be able to build a Linux that can do anything to anywhere at once. But I'm wondering, like, how do we, when we have the local interface and we're the BMC interface, how do we maintain the case that the kernel interface can be protected, but when you're in BMC mode, you can do anything you want. That's the part I'm trying to figure out.
I think that the users will just, like, if you send a command out of band and it screws up something, and the kernel doesn't know what to do there, that's, to me, is the user's fault.
I guess if you're on a BMC platform, you get to keep all the pieces.
Yes, yes.
Mm-hmm. Again, taking a cue from libnvme, where we had exactly the same problem, that the NVMe CLI was actually there in the first place, and then Keith did the libnvme for whatever, for his toy project. But in the end, we decided to move the existing NVMe CLI over to libnvme, such that we have a common code base for formatting the commands, for having the commands, blah, 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 such that we don't have to do the work twice. Because in the end, even though NDCTL might be Linux specific, at the end of the day, it still has to deal with the very same commands. So you will have to use the very same headers and everything. So it really makes sense to combine them both, that converting NDCTL as just whatever something, calling then your library there. So it is a lot of work, but in the end, it turned out to be really worth it.
Are you advocating actually combining the libraries or just the package?
Just the package. That's
okay.
Basically existing front ends to use common libraries.
Yeah, but the kernel only cares about a small subset of the commands. Like, I think for management interfaces, there's a whole command set, but for the kernel, only cares about a few things that might exist inside the kernel.
But still, they use the same headers, don't they?
There's about 5 commands that you would use in both. They're things like get and set timestamp. The rest of it is totally separate, and the message formats and everything are different. So how much you'd actually save? Remarkably little in this case. Yeah, but it maybe makes sense. Yeah. Oh, yeah, sorry. Good point. He was just saying that the same thing happens for libnvme, where they only actually have, 3 roughly commands that are in this case where they get overlapped. And sorry for not throwing the mic. Any questions?
The one benefit, really nice thing that I would have liked to do for CXL was when I noticed the libnvme integration with the NVDIM tool. The integration allowed immediate out-of-band usage for all the commands it already supported. That was pretty nice. But yeah, other than that, like we talked about the integration of both libraries and NDCTL, but it just never really clicked for me because this was so much more with the Wild West than exactly.
This will be a fun loaded question. So in the context of enabling, I guess, some vendor-specific things, are we going to keep that kernel warning splat the first time you run one?
But the position has evolved. Okay. And so at Maintainer Summit, we talked about the device pass-through topic, and we're going, and like CXL is one of the example drivers to get that new subsystem upstream. Okay. And so there are green rules about it, like this is to enable things that are not the primary function of the device. This is to give you access to vendor-specific things that the kernel should not care about yet, kind of things. It may care about it later, but yeah. So that we're going to have a path to have relaxed and more allow vendors to pass their commands.
This doesn't fit in that category at all, because
Well,
this stuff.
this doesn't, but-
No. But if we did use the firmware control for this, which is something I chatted to Jason about, it's certainly a potential, but it's not the normal use case. This is really is we win. There are no rules. You'll blow yourself away if you turn it on.
But there will be no splat.
Right, yeah, I mean, like, if you turn on the BMC mode, then all of a sudden this firmware control thing can do anything at all. Yeah.
And we had talked about a config BMC or something along those lines.
Right, to say like, this kernel is going into a security model where we absolutely trust this thing to either destroy everything or be well behaved, yeah.
Yeah.
Any distro folk like to comment on how we restrict this to keep it on BMCs? Not looking at any distro folk in particular. Apparently not. Very wise.
And yeah, here, like, I have an extra slide for anybody who's interested in the MCTP Linux stack. I think the one kind of quirky thing we have is the VDM stuff, which is kind of passed down through the switch, which does the MCTP VDM method. So I think that there's lacking a host-defined the host-defined spec for VDM. I don't know when that will be addressed, if ever.
So there are host controllers that will issue PCI VDMs for MCTP, if that's what you're asking. They exist. The problem is no one's ever published a spec. Now,
Yeah.
if that was the open question earlier. I think it's fair to say we have one, but it's not in a state for reasons of its use cases that we would. I basically have no way of testing the hardware. So yeah, if anyone can fill that one, I don't think there's any intent to define a general spec for it.
Okay.
So it's always going to be some magic platform device or similar.
I just have a question about how do you approach discovery. You said you do auto discovery of finding all the endpoints, MCT endpoints. Okay, so can you explain how?
dbus.
So do you rely on the dbus infrastructure
Yes.
on kind of a BMC type?
Yes.
Okay.
Yeah, dbus does all the magic there.
Yep.
It was all added by the OpenBMC folk.
Yep.
So hopefully they're happy with it.
Totally not libcxl at all.
Right.
Just fill in that. It's not libcxl, is what we said, because I failed to throw the microphone fast enough. Okay. Any last questions?
Yeah, that's all I have.
Okay, well,
Thank
thank
you.
you very much.